All right, let's roll. Here's the deal today. I call these double triangles, multiple triangles in one diagram. Got to find a side for me. Okay, got to find a side. Here's the issue, though. Actually, I'm not going to tell you the issue. You find out the issue on your own here with number one. I need to find side BD. Threw an X up there. So you guys have all these devices. You got law of sines. You got law of cosines. You got SOHCAHTOA from the middle of this unit. Anything you want to try to use right now to find X? Anybody want to throw anything out there to try to find side X? I'll listen. Nothing, huh? That's where we're going to roll. Start off today. What? All right, I like that. Get the diagram more detailed. Go ahead. Find the missing angles. We don't need anything special for that one. Find the missing angles. Let's get a little bit more life to our diagram. All right, looks a little better. All right, anything? Let's go. Just throw anything out. If you're wrong, who cares? It's probably going to lead us to the right answer. Go ahead. What do you got, Bella? Law of sines? All right, I'll put it up there. All right, let's see where we go with this. So law of sines. Don't write this down yet until we're solid on this. Law of sines. All right, so if we're going to try to find X, what's it across from? What's that? Keep talking. Yep. It's pretty good. Okay. Let me just summarize what Bella just said there. All right. First of all, I don't know if anybody want to do what X is across from what angle? Okay, so I don't know if you want to do 56 and then take that 300 and put it over sine of 13. No. Anybody know why? I haven't really driven home this point yet, but I am going to right now. I'm going to right now. Paul. When you use law of sines, cosines, SOHCAHTOA in the back, every single value has to come from the same triangle. Do these values come from the same triangle? No, so it's no good. It's no good. All right? And what Bella was trying to tell you guys is there is no way you are going to find side BD right away. You're not going to bust out law of sines and find BD. You cannot find BD right now. Do we see that? Do we see we do not have any information to use law of sines? We don't have enough. All right, so here's what Bella was saying. All right, don't find BD, find another side. Find another side in this diagram that I can use law of sines with. BC, or I could find what? I could find BC or I could find AB. I got enough information to do both. Can we make a class decision? BC. How many BCs do I have? Okay, I guess we win there. All right, so sorry, ABs. So let's find BC right now. And I'm going to keep quizzing you here. Why can I not use SOHCAHTOA now to find BC? Thank you, not a right triangle. So we're going to force to use, how many angles do I have? 3, so I can use law of what here if I have all 3 angles? Law of sines or cosines? Law of sines. Going to find BC. Don't call it X, by the way, because you're not finding X. You might want to use a different variable here. All right, just a heads up. You're not if you write X in there, you're not finding X, so I'll throw a Y in there. All right, here you go. I'm going to need you guys now. Let's roll. 22. Help me fill this out. Nice job. You're done. 300 over the sine of 13. On the other side of that proportion, Hey, 12, what do we got? There we go. And hey, everyone stop. Are all these values from the same triangle? Yes, that's okay. Do not mix and match sides and angles. All right, do not mix and match them. All right, cross them up. 300 times sine 43. And then we'll divide that by the sine of 13. Hey, that number you're getting on your calculator, final answer? Final answer. No, I asked that because I don't want you to. Yeah, don't round it yourself. Write it all out. Write it all out. Your wrist will take it. All good. 909.52, we all match. All right, this is what I love about today. Now when we go to find BD, we have a couple options now. We have a couple options. Remember, we have BC now. We have BC. What could we use now to find BD? I could use law of sines again. Law of cosines, you need all three sides, right? And I don't know anything about CD, so I can't use law of cosines. I can use law of sines. And ready? You're probably not thinking about it because it's been a while. Here's 56 degrees. What's that side? Opposite. What side did we just find? Hypotenuse. What uses O and H? SOA. How long have you been here? Sine. So you could use sine equals opposite over hypotenuse if you wanted to. Okay? Which way you want to do? Actually, you know what? Do it your own way. And be independent here. Do it your own way. Law of sines or sine equals opposite over hypotenuse. Decide yourself. We're all going to come up with the same result at the end. What are we going here? Nearest tenth of a foot. Make sure if you're doing law of sines or sine equals opposite over hypotenuse, all your values come from the same triangle. Make sure all degrees and all sides are from the same triangle. Take your time when you're ready. 23, when you're ready, let me know. What you got. Nobody's concerned about what you got, how you did it. And the units too. Look at this show off. Nice. Perfect. Any issues there, whether you did it law of sines or using opposite over hypotenuse? All good? Going? One doesn't make you great. We all right? All right, and the next one, all I wanted to do is make sure you could fill it in on your own. All right. Okay, from point A. Hey, elevation. There's that word again. Elevation. We looking up or we looking down? Up. So looking up to the building makes an angle of 43. Plop that 43 in for me. Angle of elevation from the ground looking up. 43 degrees. Good. Looks good. We're putting our 43 degrees right here at angle A. Ooh, from a point B that is 125 feet closer. Where are you going to put that 125? Point B, 125 feet closer. Where's everyone putting the 125? Right on AB, yep. From point A, I'm getting 125 feet closer. The angle of elevation to the top of the building measures 77 from point B. Looking up, take a look. Hey, 77. Not on the other side. 77. The horizontal looking up to the building makes 77 degrees. Find the height of the building. Okay, very similar to the last one, same predicament. Who gave us the Mason? What'd you say at the beginning of the last one? Probably would be good to do what first? Find all the angles. All right, find all the angles so I know what I'm working with. Okay, so you found all they tell me this is an above average class, so hey, why don't we change things up? Let's find the other side now. Last problem, we found the side in the middle. Anybody opposed now to finding this side? Is that all right? Go a little something different? Get you out of your comfort zone a little? All right, so let's find this side now instead and see what we can do with it to find the height of the building. What law am I going to have to use to find that side? Sines again, yep, because I have all three angles. Can I get a little help setting that up, please? Let's roll 21, little help. Yes. Nice job, Emma. And if I take a quick look, all her measurements come from the same triangle. So it's good to go. So y equals... Everyone having a good day so far. Good to hear. Buckle up tomorrow, by the way. Some intense review going on. $217.8072314. When you cross multiply, I think I did that correctly. I'm sure one of you will chirp me if I didn't. Okay, let's talk. Different ways to find x. Now that I had this side, different ways to find x. I could still use law of sines. Still, again, I could. Or I could use SOHCAHTOA. How? Now, hey, if I'm going to use SOHCAHTOA, tell me the angle you're going from now. You just found this side now. So what angle do I need to use, Sam? 43, not 77 anymore. I'm going to go from 43. And what would be the x? Opposite, and the side you found would be hypotenuse. But you got to go from 43, not 77. Or you could do law of sines again. It's up to you. All right, but make sure, again, guys, hey, you are using values from the large right triangle. All angles and sides should come from the large right triangle. So pick your method and get after it. I'll change it up. I'll do opposite over hypotenuse. What are we going on this one? Nearest foot. When you're ready. 7. Great job. 1. When you're ready, Maddie. 149 feet. Great job. Yes, Remy.
So you know how we found like y when we set up the sign and then like how we do the arrow, can we just write y?
That's fine. Yeah, I'm fine with that. Yeah. Anything else? Next one's on your own. See how well we did today. I'll put all the work up here in a second so you can check it. But 3 on your own here. I'll put up all the work in a second. When you see these double triangles, get used to, hey, I'm probably not going to be able to find what I need right away. What's up, Billy? Okay, so you got that, and then you did that over the sine. So this over sine of 53 equals, okay, again, you can't use 125. Because look, these two values and these two are triangles.
Oh.
Right? You use 43 and x, so you need to use another value. So that's why we found this side.
Oh, okay.
So now do y over the sine of, not 103, got to use values from the same triangle, 90. Okay? Figure out a side you can find first. Find that side and then say, how can I use it to find my final answer? Don't round in the middle, though. Mm-hmm. What do you mean? It's supposed to be a right angle. Yeah, it got lifted. Yeah, it's floating right angle. Yes. What's that? No, I'm gonna have you start on something else. Just make sure you take a quick check. 41 feet. I decided to use law of sines to find the middle side in between them, and then use law of sines again at the end. But you may have done differently, which is fine. But 41 feet all at the end. Just wait for people to finish up, and then we're going to start reviewing for the unit test. And I believe I did throw one, maybe two of these on the test on Friday. I think one. All right, so 41 feet. All right, you guys that are finishing up, make sure we end up with 41 feet. If not, call me over. All right, you do have the next two problems for homework tonight along with two Regents problems. But I don't want you to start on them now. Grab a textbook right now, please. All right, grab a textbook, share amongst each other, and you're going to start reviewing. In your packet, though, please go to page 54 in your packet, because that's where the answers to these are going to be. All right, everyone see where it says down at the bottom of page 54, you guys have page, it says page 615 and has the answers to them there. All right, that's what you guys are going to do for me right now. All right, you're going to go to page 615, those questions, and then you have the answers right next to you. This is everything here. We're going to start reviewing right now for Friday. Okay, so you're going to see Hills and SAS. You're going to see 30, 60, 45, 45, 90. All right, but have page 54 open right now so you can see your answers as you do them. And of course, call me over if there's any issues. This is not homework. You have to finish it. We're going to continue on with it tomorrow when we review in class.